This video is on solving literal equations. Again, literal equations, when we solve them, we are rewriting the equation into a different format to solve for one of the variables and to isolate the one variable we need. So our example is A equals 1/2 BH. This is the area of a triangle. Area equals 1/2 base times height. We want to solve for B. So I'm going to rewrite this problem so I can work it out. A equals 1/2 BH. I want to solve for B, so I'm going to circle B in pink. Now remember, we're using SADMAP, so we want to add and subtract away first. On this problem, we have no addition or subtraction signs that are attached to the B, so we don't need to worry about addition and subtraction. Now we go to division multiplication. We have a 1/2 times B, and we have an H times B. What this really is happening here is we are dividing by 2. This is actually a division of 2. We want to get rid of the fraction first if possible by multiplying by the reciprocal. We want to multiply both sides by the reciprocal of 1/2, which is 2 over 1. So if we multiply both sides by 2, we will have 2a equals BH, because this 2 and that 2 will eliminate. The B is not alone yet, so I'm going to circle that B again, and then I look to see how do I get the H off of it. We have a B times H, so in order to get the H off of the B, we want to undo multiplication with the inverse, which is division. So we're going to divide both sides, so everything, by H. When we divide by H, the H and H will cross out, and then the B will be completely alone now. So we can say that B equals. We come over here, and this cannot simplify any further. There is nothing else that will simplify, so our final answer is B equals 2a divided by H. Please understand that this is not 2 plus a, so it does not separate into two fractions. This is one term. This is one numerator and one denominator. So we would not say 2 over H plus a over H. There is no addition sign in here. It stays as 2a over H. On this next example, we have V equals 1/3 pi r squared H. This is the volume of a cone, and we're going to solve for H. So I'm going to rewrite this. V equals 1/3 pi r squared H. I'm going to circle the H because that's what I want to get rid of. I want to get alone. We look for addition, subtraction. There's no adding or subtracting symbols attached to the H at all, so I can go straight to multiplication, division. I look to see I have a fraction on here, and that's like we had on here. I want to get rid of the fraction first. I want to multiply by the reciprocal of that fraction. So if I multiply by the reciprocal of 1/3, which is 3, so I'm going to multiply both sides by 3. We're left with 3v equals. The 3 and the 1/3 will cancel each other out. So we'll be left with pi r squared H. Again, my H is still not alone, so I'm going to circle my H in pink again. And I need to get the pi and r squared off of the H. Now, pi and r squared are both multiplied to the H because this is all connected. This is one term, all connected through multiplication. So I can get rid of all of the multiplication at one time by dividing. So I can divide both sides by everything attached to the H, which is pi r squared on both sides. So if I divide by pi, pi will go away, r squared will go away, and we will have H completely alone. So then we can go straight into our answer, which is H equals. So we look on this side to see if anything can simplify. 3v over pi r squared. This stays as it is because there's nothing that can simplify. And again, just like this last one, 3v is an entire numerator altogether, and pi r squared is the entire denominator altogether. We do not split them up. So H is equal to 3v divided by pi r squared. This next example is a equals pi r squared. This is the area of a circle formula. We're going to solve for r. So we have a equals pi r squared. I'm going to circle, we want to solve for r, so I'm going to circle the r. We look for addition, subtraction first. There's nothing added or subtracted to this, so we go straight to multiplication, division. We have a pi and a 2 on here. Now the pi is multiplied to the r, but the 2 is an exponent. Now remember, with SADMEP, we can't do the e until after we finish the multiplication and division. So we have to get rid of the multiplication first. So our next step will be to divide, since pi is multiplied, we're going to divide both sides by pi. And we'll have a over pi is equal to, since the pi's cancel out here, we'll have r squared. R is still not alone yet, so I want to circle the r so that I know that I have to get that alone. We've done all the multiplication division. Now we go to e, exponents. 2 is an exponent. We need to undo a square by doing the inverse. The inverse of an exponent is a radical or a root. So I'm going to, the inverse of squaring something is taking the square root of it. When you take the square root of a square, they cancel each other out. So we will have r completely alone. Once we have r completely alone, we can write out our answer, r equals. So over here, we're just going to rewrite this. It's the square root of a over pi. Be careful to make sure that a over pi is completely inside that square root symbol and not outside of it. So remember, the inverse of a square is a square root. So in order to get rid of an exponent, you have to take the radical of it. And because we took the square root at the end, it has to encompass everything on that side. That's why both the a and the pi are inside that radical symbol. Nothing is outside of it. This next example is a equals 1/2 h times b1 plus b2. This is the area of a trapezoid. So rewriting it, a equals 1/2 h times b1 plus b2, close parentheses. We want to solve for b2, which is the base 2, the second base. I'm going to circle that. Now remember, we are solving, we're not trying to simplify right now. A lot of people would want to distribute to get rid of the parentheses, but that will actually make it much more difficult to solve. The b sub 2, which is what we want to solve for, is already kind of alone. There's nothing directly attached to it, and if we were to distribute, we would put more onto it. So let's leave this as it is. We want to get everything on the other side right away instead of putting more onto that piece. Now remember, the addition in here, yes, there is addition, but that is inside the parentheses, which we can't touch yet. So any addition subtraction would have to be outside of the parentheses. So we cannot touch the inside at all. Not yet. So we have to look at addition subtraction outside the parentheses, which there is none. So we will go to multiplication and division. Just like before, this has a fraction. We want to get rid of that fraction first by multiplying both sides by the reciprocal of 1 over 2. The reciprocal is 2 over 1, or just 2. So now we have 2a equals the 1/2, that division, and that multiplication will go away. Now we're left with the h, parentheses, b1 plus b2, close parentheses. Again, I'm going to circle my b sub 2, because that's what I want to get alone. And again, we're not going to distribute because that would just put more onto that circled part. And I don't want to put anything else on it if I can help it. So now we have to worry about the h that's attached to the parentheses, because again, we cannot touch the inside until we get everything off of it first. So the h is being multiplied to that parentheses. We're going to divide everything by h. So we will have 2a over h equals. Now, this h on the bottom automatically eliminates with the h on the top. It doesn't even affect the inside. So now we're left with b1 plus b2. And because the h was attached to the parentheses can go away now. Because there's nothing attached to it, all that's left is what was inside the parentheses. So I have b sub 2 is still not alone yet. There are no exponents, and there are no more parentheses. So what do? We actually have to start back over with SADMAP. We want to see if there's anything added or subtracted that we can get rid of now, because now we're inside the parentheses, so we have to start back over. We do have an addition sign, which means that there is some type of addition or subtraction. We don't want to touch b sub 2, so we look at b sub 1. B sub 1 is positive, so that means we want to subtract that b sub 1 to the other side. So we're going to subtract b sub 1 from both sides. And that will eliminate our b sub 1. Once that b sub 1 is gone, we have a positive b sub 2, and that's exactly what we want. So we will have our answer. We'll have b sub 2 equals. Now, what was left in purple is going to stay in the front because that was already there. So we're going to have 2a over h. Then we subtracted the b sub 1. So that does not go in the numerator, it does not go in the denominator, it goes off to the side. So minus b sub 1. That does not have the h in the denominator because the h was in the purple part, not in the orange. So this is our final answer. That b sub 1 is off to the side being subtracted with the denominator of 1. So the color coding might be able to help you if you're not sure of where these numbers came from. Our last example is f equals g m sub 1 times m sub 2 divided by d squared. And I believe that's a force equation. So f equals g m sub 1 times m sub 2 divided by d squared. Now this is the complicated version. This is a complicated equation, which is why it's on our notes. So I circled d because that's what we're trying to solve for. Now, we have a fraction, and actually we want to get rid of the fraction first if possible. And because the letter we want is in the denominator, we need to fix this so it's no longer in the denominator. What we want to do is multiply both sides by d squared. Everything in the denominator, I want to be able to put on the numerator. So now what we have is d squared f equals this d squared and this d squared completely go away. So now I don't even have a denominator. I have g m sub 1 m sub 2. Now I have no denominator, which makes things a lot easier. So now I can easily solve for the letter d. So now what's attached to d is we have a 2, which is the squared, and the f, which is multiplied. So there is no addition or subtraction in this problem, so I go straight to multiplication division. So the f is being multiplied by the d, so that's what I need to get off next. I need to divide everything by f. And now I'm going to have a new denominator, but that's okay because it's no longer the letter we want alone. So we will have d squared equals g times m1 times m2 divided by all of that over f, because the f's over here can go away. Now, what's still left is we have that squared on d. We need to get rid of the squared. It is an exponent, so to undo a square is we take the square root, just like we did on our area equals pi r squared. We want to get rid of the square by square rooting both sides. the square and the square root will cancel each other out. So we'll be left with only d, so d equals. Now remember, this orange square root went over everything on this side. So everything in purple has to be inside of that square root symbol. So I'm going to write out the g, m sub 1, m sub 2, all of that over f, and then I'm going to put my square root symbol and make it large enough to encompass everything. And that is our final answer. So when you solve literal equations, you solve them the same way you would a normal multi-step equation. It's just you don't see as many numbers in it, and that's okay. You do it the same way we've always done solving multi-step equations.